Okay, hi guys, welcome to chapter 5 light recap. Just mainly want to go through certain points with you to prepare you for your end of year exam. Okay, so first of all, right, we need to know, right, that light is a single ray of light, so therefore there is only one ray of light. But for beam, right, there is multiple rays of light, so therefore you see down here I have drawn three rays, sorry. So you can have like 3 rays, 10 rays, a million ray. That is a beam of light. Okay, the second pointer that you need to know is that light cannot be bent, it can only travel in a straight line. So therefore, do not draw any curved lines in your papers and such because you'll be marked as wrong. Okay, moving on. There's something called a parallel beam. A parallel beam is one whereby, right, all three rays, right, inside this beam, right, they are all parallel to each other. So therefore, we use application like this, like for example, lasers and such. Divergent beam, right, is one whereby the rays, right, they are all going in different directions and they're all spreading out from each other. So therefore we use it in, like for example, lighthouse, torchlight, the flame from a fire. Those are all divergent beam. Okay, convergent beam on the other hand, right, is one whereby all the rays are like coming to one single point down here, like a single point here. So therefore they are all converging into one place, and an example of it is a magnifying glass. The next pointer that I need to note is speed of light is 3 times 10 to the power 8 meter per second. So therefore light is actually very fast. The next thing you need to know is that you are able to see an object. Like for example, I can see my handphone, I can see my wallet. Is because, right, light is being reflected off that surface and into my eyes. The 6 properties of plane mirror refraction are, first of all, upright. So one example when you think of upright is when I look at myself in the mirror, I don't see my legs. When I see at my eye level, I only see my eyes. My legs will see my legs. Imagine my legs got eyes lah. Okay, so therefore it will always be upright. So therefore, if I am up, I look inside a mirror, I am facing up also. Virtual means, right, that I cannot touch the image. Okay, same size. For plane mirror, it must be same size. I don't expect to see myself in the mirror. Like for example, I'm now 90 kg, my size is fat. Okay, I don't expect to see myself looking in the mirror and looking slim. So that's why, right, when I look at the plane mirror itself, right, it's a true reflection in terms of what my size is. Okay, laterally inverted, it means, right, my left hand when I look in the mirror, right, it's my right hand. My right hand, I look inside the mirror, is my left hand, and that's the meaning of laterally inverted. Object distance to mirror is equal to the distance image to mirror. It means, right, that for example, down here I have 4 cm, my object to my mirror is 4 cm, my image to object is also 4 cm. Okay, the next pointer, point number 7, the angle of incidence, right, you must always take it with respect to the normal. This is very important. So if my normal, right, it means, right, it is 90 degrees to the surface that I have. So this is my surface, my normal is here, it must be 90 degrees. So therefore, my angle of incidence is the one that I measure with respect to the normal. My incident beam is coming here. This is my angle I. This is my angle of incidence. And the angle of incidence, the angle will always be the same to the angle of reflection. So therefore, if I is 30 degrees, R will also be 30 degrees. Okay, a common misconception that exams will give you is, like for example, they will tell you this angle down here is 20 degrees. Okay, then a lot of students will always think, oh, this angle down here 20 degrees, that means incident angle. But no, you must always take with respect to the normal, which is 90 minus 20, 70 degrees. Okay, so this is how you must always do it, with respect to the normal. Point number 8, okay, we're going to talk about regular reflection and irregular reflection. Regular reflection, right, is one whereby I have 3 beams here. They are all parallel to each other. When they reflect across a flat surface down here, all 3 beams coming out, all the reflected beams coming out, right, they will all be parallel to one another. But if I have an irregular surface, oops, sorry, I think this drawing is wrong. Okay, hold on. If I have an irregular surface, I shine 3 beams, 1, 2, 3. Okay, my reflected ray will look something like this. Okay, you can see, right, that for this, right, my 3 parallel beams coming in, but then yet the reflected rays, right, they are all in different directions. So therefore, right, this doesn't provide a clear image. Okay, an example of this is like, for example, if I have a very, very smooth pond, okay, a smooth lake, whereby there's no movement of water, right, this will be a plane mirror reflection. I can see like the place of a Toblerone, the mountain, I can see using the lake, oh, it's very clear. But if there is like wind blowing against the surface, right, then the water surface will be something like this. You will not cause a clear reflection. Okay, so there are three types of mirror. First of all, plane mirror, convex mirror, and concave mirror. Okay, a plane mirror, you know that it's a flat surface like this. Okay, convex mirror, I don't explain so much first, but let's talk about concave. I like to use the word cave. Okay, when I think of the word cave, right, it's like me walking into a cave. The cave has a hole like this. So that's why, right, concave mirror, I like to remember it as I'm walking into the cave. Okay, concave mirror, right, the properties are, first of all, it is virtual, upright, and magnified. Okay, so right, the reason why we use concave mirror, right, is because of this function purposely only. Okay, magnified. So like, for example, if I want to pop my pimples and such, okay, I will like to go close to the mirror and magnify that portion of my body that I want to pop the pimple from. So we do use it a lot in beauty mirror and dentist mirror also. Convex mirror, on the other hand, right, it's one whereby you're going into the back of the cave. So therefore, right, you're going to face like the belly like that. Okay, so the properties are virtual, upright, diminish. Okay, but because it is diminished, right, it actually provides us a greater field of view. So examples that we use it is like, for example, blind spot mirror, surveillance mirror, and such. So like, you go to 7-Eleven in the old days, my generation, okay, you will see there's this mirror down there at the corner of the store, so that the storekeeper is able to see the entire store based on that mirror itself, to prevent people from shoplifting and such. Okay, a common mistake that a lot of students do, right, is that they change the mirror, right, to the word camera. Okay, camera doesn't use mirrors. Okay, please use the proper word, surveillance mirror, not surveillance camera. Surveillance mirror. Okay, plane mirror, right, you just refer to the previous pointer. So the examples that we use are like, for example, dance mirror or toilet mirror. Okay, so for the users of light, we have infrared radiation. We use it like, for example, now you see COVID situation, there's a lot of infrared thermometer. You walk through the gantry down there, then you see the lady down there sitting down there, then you look at this screen. They actually use an infrared thermometer to measure your temperature. Okay, we also do use it in security camera. For example, at night, then when it's very dark, right, we actually use infrared to see the image. Okay, TV remote, we also do use infrared, motion sensor also. So one negative thing about infrared radiation, right, is that too much of it is actually a form of radiation, and it can actually cause global warming. So the next type of light we'll talk about is ultraviolet. Okay, we mainly use it for sterilization. So like, if you go to the dentist, you see there's this small little oven down there that the dentist will put the tools inside, and inside the light is usually blue color, that kind of stuff. We are mainly using it to sterilize the bacteria and viruses by killing it with ultraviolet light. Okay, so another common usage of ultraviolet light, right, is one whereby we use in sun tanning salon. Okay, it's not really found common in Singapore. It's usually in the Angmoh countries. The Americans, they like to suntan in the bed, and then it's technically like burning your skin in a controlled environment. Okay, so one negative effect about ultraviolet, right, is the sun. Okay, the sun actually has a lot of ultraviolet light. So the sun shines on you, there's a lot of ultraviolet light, and actually causes cancer. So skin cancer is a common occurrence due to ultraviolet light. Okay, visible light is one whereby we use in our plants. You mainly need to have photosynthesis, and the most important thing about visible light is that if I don't have visible light, I can't see anything. So that's why, right, it allows us to see. Okay, the negative thing about visible light is, right, it actually causes deterioration of artwork. So like your Mona Lisa painting, that kind of stuff, you can't put it out in the sun, because when you put it out in the sun, right, the artwork will be damaged. Okay, And another thing is light pollution. So like I myself, I don't like to sleep in an environment whereby I have spotlight shining on my face. I need to sleep in complete darkness. So if there is too much light shining at you, right, it's considered as a form of light pollution also. Okay, so light pollution is very common in cities whereby the street light is always on, and no matter how you draw your curtains, right, there'll be some form of light that will seep into your bedroom. Okay, so right, this is the end for the NA syllabus. So now on to add on to the express syllabus. Okay, so refraction, right? I know your teachers have taught you certain standards in terms of how you answer the question, but I think I would like to just simplify for you into 3 different steps. Okay, step 1, identify the optical density. So you're going to take a look at the example here, down here. Okay, the incident ray is down here. Okay, so right, we identify that it is from air to glass. Okay, so we know, right, that air has a lower optical density than glass. So right, you just need to follow your example. So it's either option A, which is all those in green, or option B, which is all those in black. So right, option A, air to glass. Okay, I first of all know that it goes from a lower optical density to a higher optical density, because the air is of a lower optical density, the glass is of a higher optical density. So therefore, we know, right, that the next thing you need to compare the speed of light. If I am going from you need to know, right, that for low optical density medium, right, the light travels faster. For high optical density, the light travels slower. So therefore, in this case, right, we'll just be following all the black color. So therefore, we know that the speed of light will decrease. Okay, so I think I better write it down first. Hold on. So the first pointer down here, we know, right, is that change color. Okay, 1, it goes from a low optical density. I'm too lazy to spell. Please spell it out next time. Low optical density to a high optical density. Okay. The second thing that you need to state, right, is that the speed of light decreases. Okay, decreases. So after that, right, you know that the speed of light decreases. Step 3, explain how speed of light affects the bending of light. So if my speed of light is slowing down, right, it will bend towards the normal. So I am going to draw for you a normal here. Okay, so right, the speed of light, it will bend towards the normal, so the original path is supposedly like that. Okay, so right, I will bend towards the normal. Okay, I'm bending towards the normal. Okay, so long there's a bend in this direction, then that's fine already. Okay, so right, then you need to say the third pointer is bend towards normal. Okay, so now we're going to go on to the next example, which is from glass to air. Okay, glass to air, you need to identify first of all, right, the optical density. Okay, glass versus air. Glass has a higher optical density, air has a lower optical density. So we are now going to follow all the green color things. Okay, so right, we know that next thing, right, you need to write, okay, I better write down also. 1, you need to say that speed of light from high optical density to low optical density. Then the next pointer you need to say is that the speed of light will increase because I'm based on this. Then the last pointer that you need to say, right, is 3, it bends away from normal. Okay, so like I say again, I'm going to draw the normal again. Okay, original path was like that. Okay, so now it will bend away from normal. You bend away from normal. So this is how I like to explain my answers using the 3-step approach for refraction. Okay, first of all, identify the optical density. Are you going from high to low or low to high? Okay, next thing, compare the speed of light. If I'm going from low to high, I'm slowing down. If I'm going from high to low, I am increasing my speed. Then after that, you explain from step 3, which is, do I bend towards the normal or do I bend away from the normal? Okay, this is the explanation for rarefaction. Okay, so the last one for the express syllabus, right, is the bending of light, the dispersion of light. Okay, you just need to first of all remember the various color of a rainbow: red, orange, yellow, green, blue, indigo, violet. And you need to know that red bends the least, violet bends the most. So that's why my original path is going like this. My red bends the least, my violet bends the most. So that's the main explanation in terms of what dispersion is. Okay, so now you're going on to certain AFL questions. Please do it. There'll be some model answer that will be given to you, and please recap on it. If you have any questions, please feel free to find your individual science teachers. Thank you.